Good morning, students. So this is your science teacher, Mr. Zhong. So today we're going to talk about the chapter of energy. Okay. So energy in Chinese called 能量. Okay. This is a very important concept because basically all actions that you encounter in daily life they need energy. Okay. So uh, you need to. You're going to run, speak, or do whatever action, you need all energy. Okay, all needs energy. You need energy to support these actions. So that's why we need to eat food because food itself contains energy. And that's why when you do not if you do not have enough food, you will starve and you will die because your cell cannot perform normal activities. Okay, so similar to this lamp. Okay, so because these lights, okay, these lights, they need this energy. They need to be power, and all the power are probably stored in the battery or your main circuit. Okay, so even lighting, the main circuit. The main circuit, okay. Main circuit means the uh, circuit that you usually use in your home. Okay, the one that you put a plug on the wall and it will connect to the main circuit and provide you with the energy. And also that's why we can cook food because cooking also needs energy. Okay, cooking you need heat energy in order to make your food ready to be eaten. And at the end, a moving machine also needs energy because you need to move all these objects, okay, and all these need energy. Okay, so basically many action in this world we need energy to make them work. Okay, so that's why this is very important. And energy is one very important concept. Okay, so first of all, energy has a lot of form. Okay, can have a lot of form, which means that although energy they can be expressed in probably in kinetic energy, heat energy, or potential energy. Okay. Uh, in Chinese, that basically means 能量 have a lot of different form 形态. Okay. So no matter kinetic 动能 heat 热能. Okay, and potential, this is 势能. Okay, so first of all, there's a lot of different form, and energy can be converted into different form. For example, electrical, for example, lamp. Okay, so lamp is something like this. Okay, so my pool's drawing skills anyway. So it gives out light and heat. Okay, so there's energy conversion. Okay, energy conversion. Let me write it down here. Energy conversion. 能量轉化. So from electrical energy, because you need electricity. Okay, and it converts the electricity it converts the electrical energy into into light energy and heat energy. So energy can be converted from form to form, different form. Okay, depends on what action you're performing. Okay, and the last one, let me write down here. So energy cannot be created nor destroyed. Okay, so I think this is the three most important concepts for this chapter. Okay, so energy have different forms. So we're going to learn about that in the later parts. And energy can be converted from form to form. Okay, so they're interchangeable. And the last one, energy cannot be created nor destroyed. Okay, so right now we're going to talk about different forms of energy. Okay, so let's start with the heat energy. Okay, so heat energy, first of all, heat energy increase the temperature of an object. For example, if you stay under the sun, okay, let's say this is you. Okay, this is you. Okay, you feel hot. So you feel hot under the sun. Okay, why? Oh, very simple. Because first of all, the sun gives out light, and this light would then heat up the air particle, and that's why. And when they when they pass the energy to you, you feel hot. Okay, so for some student, if you are clever enough, you already see there is some energy conversion. So that is from the light energy to the heat energy. Okay. So similarly, okay, Bunsen burner. Okay, Bunsen burner. Of course, it will also give up light energy. Sorry, heat energy. Heat energy. Okay. So Bunsen burner. Of course, we're talking about the light one. Okay, with flame. Oh, I would say Bunsen flame maybe better. Okay, Bunsen flame will give out not only heat energy but also light energy. Okay. And by the way, so temperature. Okay. So temperature, you may consider this is the measurement of talking about an object, how hot it is, or the hotness. Okay. While another one, so sound energy. Okay. Sound energy is produced by the vibration of an object. Okay. Vibration. Vibration here means you may consider is shaking, but usually we're talking about shaking around a fixed position. A fixed position. So, for example, there's no exact movement, but just shaking. For example, um, let's consider this guitar. Okay, so when you see guitar, there's some line here, and these are called the string. In Chinese, called yin. So when you try to click those strings, so it originally would in this shape, okay, in this shape, okay, if you do nothing. However, when you're trying to click it, okay, so when you're trying to click it, so it will trying to have some movement here, and this we call it this string is vibrating, okay, vibrating, 震动, okay, and this vibration will cause the movement of the air particle, and that's why it will give you some sound. So the particle around was also vibrated, being heated by the string and caused the movement. and this movement will give you the sound energy. Okay, so this is the whole story. That's why there's no sound, or you cannot speak, or no one can hear you in the space. Okay, so no sound energy in space or in a place vacuum, 真空. The reason very simple, because there's no air particle. Okay, even if there's anything vibrates, so no we call these as the medium 介質或者叫介體. Okay, so this is the one as the subject that pass the energy to us. But however, in vacuum or space, there's no air. That's why no sound energy. Okay, so there's also some idea. For example, drum. When you hit the drum, you will feel that surface is vibrating, 震動. Okay. Also, the speaker. If you have a speaker on your desktop, your personal computer, you can also try to put your finger near the speaker. When you touch the surface, you also feel that it was shaking when it was speaking or emitting sound. Okay, so this is more simple. So light energy. So there's a lot of example that will give up heat energy. For example, sun, fire, and yeah, these two also give up light energy. So this energy is very important because they enable us to see things. Otherwise, we see nothing. We see nothing. Okay, so candle, lamp, torch. This is torch. Okay, this is a torch. Also give out light energy. So, by the way, can you guess the energy conversion in this example? Can anyone tell me? Okay, so obviously the energy is converted into light energy, and probably there's also some heat energy. So as we've mentioned before, so energy can only be converted from one to another one. So what energy did we have at the very beginning? And where are those energies stored? So some of you may already notice that, oh, we have the battery, we need the battery. Okay, so what does the energy store inside the battery? Okay, so what it is? Okay, so that is this one. Okay, so sorry for the apple. Okay, so this is the full word, the full phrase, chemical energy. Chemical energy, Chinese called 化學能. So this is a form of energy, and this is the way of food and fuel. How do they store the energy? Fuel here means something that can be burned, things that can be burned to release heat energy. Okay, so here usually we would refer to the oil, to the liquefied petroleum gases. These here means 燃料. Okay, so they store the chemical energy. That's why when they were burned after this process, energy can be converted into heat, because this is the energy conversion from chemical to heat energy. Okay, so heat energy and light energy. So the conversion is not limited. They can also be converted from one type to another type. Just now we have the torch example. Okay, that is one of the example of we converting the chemical energy in the battery to the electrical energy, which we're going to mention it later. electrical energy and then to the heat and light energy at the end. Okay, so this is one very common example. So as we have mentioned, so fuel contain chemical energy. This is the thing that we always use when we're going to heat up or burn something, when you're going to cook your food. And the reason why we need food, because food itself contains chemical energy. This would be released to support our daily activities. This is very important. That's why we need food. So electrical energy, this is always appear in our daily life, especially when we're going to use these electrical appliance. Okay, so electrical appliance, they are the device that require electrical energy to work, to run. So these are called Din He. Okay, so basically TV or computer or even the mobile phone you're using. Okay, they also need electrical energy. So this is a very useful form. So where you can get the electrical energy by putting a plug on the wall, you can already obtain the electrical energy. Okay, so we get the electrical energy from cell. Here they means means the battery after the conversion from chemical to electrical. Okay. Quite a lot of students they thought that the battery contain electrical energy. No, this is a very common mistake. So battery do not contain electrical energy. Okay, they just contain chemical. And when you are ready to use, then the chemical energy will convert it into electrical energy and converted to anything that any different kind of energy depends on the device. So it depends on the TV or the computer. Okay. So solar cell here. Solar cell is here means the device that requires sun to run to harness the energy. So 太阳能电池. Okay, and power plants. Power plants here, in fact, they mean nothing about segment. Here, power plants, this whole phrase meaning factory that the factory that provide us energy by burning coal or natural gas. Okay, 发电厂. So these are the battery and the power plants here. So some places, electrical energy come from nuclear energy. So in Hong Kong, there's some of our electrical energy come from a place called Daya Bay. Daya Bay called Dai Nga Wan. If I'm correct, this is a place at the northeast of Hong Kong. Northeast. Okay. So Daya Bay Power Station, Dai Nga Wan 核電廠. Okay, even Hong Kong, we also have some energy come from the nuclear plants. Kinetic energy. So kinetic here, kinetic energy means 動能. So based on the name, you can tell that we are talking about a moving object. Moving object. So every moving object, they have kinetic energy. Every, as long as they are moving. The faster they move, the more kinetic energy it has. Now, okay, now think about it. So What happens if there's two objects that with the same speed? Which one has more kinetic energy? The heavier one or the lighter one? So these two gentlemen, they are running. They're running at the same speed, running as fast as you. So same speed. However, this gentleman A said, "Oh, I have more kinetic energy than you." Why do they say so? Okay. Now imagine one situation. So there is a bicycle, something like that. Very nice bicycle. And another is a truck. It's a truck. Now, both of them are traveling in the same speed. Same speed. Okay. Imagine you are being heated. One person being heated by a bicycle. One person being heated by a truck. Which one will be, or which one will you going to be? Okay. You are hoping which of you are in which situation. Okay. So obviously this person will suffer more. Okay, they will get hurt more because although they are in the same truck, but the truck, why truck they will cause more harm? They're in the same speed. The reason very simple, because truck is more heavier. Okay, more heavier. While the bicycle is lighter. So which means that kinetic energy is not only depends on speed, kinetic energy. Sometimes we just use the phrase kg, kinetic energy. Not only depends on speed, but at the same time also depends on the mass. Okay, mass of that object. Mass here means 質量. How many substance do you have? Okay, 你本身有幾多嘢，幾多物質 Okay, if you have more speed, more mass, then you have more kg. Okay, so probably this is the most difficult one, potential energy. As we have mentioned, potential energy in Chinese called 勢能. Okay, so you can consider potential energy is the energy which store. Okay, it is somehow store energy. But here we are referring store mechanical energy. Mechanical energy. So here means that it is stored by physical action. Physical action. Okay, for example, when you're trying to squeeze, when you're going to squeeze, let's say a football. Okay, it was a football, not squeeze, but we hit it. Okay, there's a football here. Okay, so when you're going to hit it, okay, you punch it. Okay, punch it. So the shape of the football will change because of your punch. Because of your punch, and it will try to return its original shape. Well, this is the energy that they store, potential energy. Okay, so this is the kinetic, the heat to potential energy, the deformed football. Okay，改變形狀嘅足球。Or when you scratch something, for example, a very simple one, rubber band. Rubber band. Okay, when you try to scratch it, it will return to its original position in a very quick way. Or a balloon, this one, a balloon. Imagine if you release this torque, what will happen? So the potential energy will be converted to kinetic energy because this balloon will move very quickly. Okay, and this one, Jack in the Box. I wonder, do you know what it is? Jack in the Box is something that's inside boxes. Okay, and after some time or when you do something, suddenly there's something that jump out immediately. Okay, scare you away. Okay, so this is the Jack in the Box. Jack in the Box. Why this is related to the word potential energy? Because of this strain. Okay, so this spring. Okay, spring 彈簧. Okay, so when you're trying to compress a spring, it also store potential energy because these are some store physical action, mechanical energy. Okay, so this is also potential energy. And the last one, we also describe and write that object has potential energy. Imagine if we lift a rock upward, okay? If we lift a rock upward, we would say that rock at this position has higher potential energy, okay? Because it is at a higher position. So you can just think of what happened if I suddenly release this rock. This rock will fall down immediately, okay? So to release the potential energy. So right now the following slide would be some energy conversion which use it for your practice. This is a sound energy. Sound energy. Here you may consider here that there's a missing one energy conversion. So this is the chemical energy stored in the cell or in the battery. Okay, so before passing the energy to the light bulb, they have to first convert it into the electrical energy first. Okay, so that's why the energy conversion, there's some missing here. It should be first convert to the electrical energy, then to the heat and light energy. Okay, so this should be better, this one. Similarly, okay, missing electrical energy here. Okay, so again, better for illustration. This is also another toy car that storing the energy to the spring, 弹簧, and then after you release it, it will convert it from potential energy to kinetic energy. So the energy conversion would be, first of all, there is the kinetic energy. from your hand converted to the potential energy of the spring inside the toy car. And after, when you release it, it will be turned into kinetic energy of the toy car. Okay, so this is energy conversion. Again, as we've mentioned before, the energy stored inside the balloon, and then it will convert it into kinetic energy and probably some sound energy as well. This is a little bit difficult, but you may just see as example. So here, after the rubbing, after the rub, after the rubbing, uh, there may be some build up of charge. Okay, some build up, building up of charge. Charge here means 電荷, and this would cause some electrostatic interaction. Electrostatic interaction. Electrostatic in Chinese called 静電. Okay, so you just learn it as an example will do. We won't go too deep here. But basically, it will have some energy conversion from kinetic to electrical energy. Well, this is again, you're burning a magnesium ripple. Magnesium is a kind of metal. Ripple means okay. So basically, it's describing the slide of metal, magnesium. When you burn it, it will turn the chemical energy into heat and light energy. This one is a little bit interesting because this is talking about when we're going to heat up the air inside. The air inside. Okay, so they will be heated and expand. Expansion. Expansion in Chinese it means that increase in volume. 膨脹. Okay. So as the air move, it will generate some sound. It will generate some sound. So this is one of, or you may consider as a example of a musical instruments. 音樂樂器. Okay, so there's an extension here. When talking about energy, there's very, very important that, yeah, in our daily life, we need a lot of energy because we need to probably turn on our air conditioner. When we're going to use our mobile phone, we need to charge it up. And even for cooking our food, we need energy as well. We need fuel. But however, if we because not all energy source is renewable. Okay, renewable you may know it in Chinese called 可再生. Okay, so the full phrase would be the renewable 可再生能源 renewable energy. So these are the example of renewable energy. So hydroelectric 水力發電 solar power 太陽能 wind power 風能 tidal power 潮汐能 geothermal power 地熱能 Nuclear power. No. Nuclear power is non-renewable energy. Of course, here we did not mention uh, the main energy source that we use is fossil fuel. Fossil fuel. 化石燃料. We are now using probably oil, coal, natural gas. Okay, so of course these fossil fuel are also non-renewable energy. Okay, non-renewable energy. Non-renewable. So how to compare renewable and non-renewable? Basically, you can compare their amount. Their amount. Okay. So renewable energy, the amount is unlimited. Unlimited. At least to the scale of human. Okay. Unlimited. Some of you may say that, oh, Mr. Jung, solar power is not unlimited, so the sun will use up their fuel one day in future. Yes, but we are talking about the scale of human only. Okay, so you need not to mention about something like 5 billion years later. No need to think about it. As long as you think that, oh, this is relative, the amount is unlimited. Okay, on the renewable, they are limited. Okay, this is the major difference. So hydroelectric power, as mentioned before, we use high dam to store water and allow the water to flow down. Allow these water to flow down into the lower position. And when they are passing through these gates, so when you're passing with this building, will allow them to pass through some turbine. Turbine means boiler. Oh, so this would then generate electricity. Electricity. So this is, if you think about in terms of energy conversion, would be potential energy to electrical energy. Electrical energy. Okay. So this is hydroelectric power. Hydroelectric power, in fact, there's some disadvantage. That is, first of all, there's very rare place for building this high dam. Okay, so you have to depend on the location that you have. Moreover, when you build the high dam here, it will cause great harm to the environment. It will change the environment forever. So you may consider that, okay, the downstream 下游, they originally before the building of high dam, they have a lot of water. They receive the water from the upstream. However, after building the high dam, because of the dam, they trap all the water upward. Okay, so eventually you may consider the plantation, the plants, the crops, the environment, the trees, the grass, the river, whatever, all of them will be affected by this building. Okay, so there may be some drought, some extremely dry. The plantation may be no longer able to survive. Okay, so this is the disadvantage of hydroelectric power. Solar power. Well, solar power, as mentioned before, it is called harnessing the sun energy, sorry, the light energy to the electrical energy, electrical energy, and or heat energy. I wonder if you have ever seen this on the roof of some country, not in Hong. I think you can still find some in the Cyclone, but not in the rural area, and so not in the urban area. Okay, so this one is kind of water tank. So some family they use solar power to heat up the water. Okay, just and store the hot water and for bathing for any other use as well. Okay, so solar power we need these solar panel 太阳能板. This is the key of converting the light into electrical energy. Okay, so there might be some disadvantage as well. When you're going to create the solar panel, there's some pollution as well during the manufacture of a solar panel. Okay, so the industry for making solar panel is uh, highly associated with the pollution. Okay, secondly, the efficiency efficiency of the solar panel is still improving. Right now, as I remember, only around 20% something. Let's say 23, maybe, or 21 or something. So which means that only 20 something percentage of the light is utilized. Most of them are wasted. Okay, so well, maybe this need to depends on the technological advancement. So far we can do nothing. And also it does take up space. Okay, so you need to one with extremely high amount of sunshine. And the last one would be about the time or the availability of the sunshine. A very simple question. You don't have sun at the night. You have to base on a certain storage in order to make good use of the solar energy. Okay, maybe you need some battery as well. Wind power. Okay, so wind power in fact is quite common in the European country, especially like Germany. Yeah, Germany, Austria, etc. Okay, so they need windmill. This is going to collect the wind energy and turn the kinetic energy to the electrical energy. So electrical energy through this generator. Generator here means 發電機. Okay, turbine as well. Yeah, this is pollutionless, so no pollution. However, it takes up space, a lot of space, and also you can't place these near the residential area. Okay, it's far from a living place. The reason is very simple. It is extremely noisy. Extremely noisy. Okay, and because of its size, you have to make sure that the weather is appropriate, because you can't put it like in Hong Kong, you can't put too much. You can't because of the typhoon. During typhoon season, this may be easily damaged. Okay, so Hong Kong may not be a very good place for placing this. Only in some some country or some area with mild wind speed. I heard that these windmill, they have to even turn it off when the wind is too strong. If this is too strong, this has to be turned off because otherwise it will be damaged. It will be damaged by the strong wind. So quite weird to hear about it. Okay. Okay. So this one, tidal power, take note. So this can only build along the coast. Okay. So it is based on the concept of the difference of the water level. Water level. They have difference. So when they allow the water to go through it, again, similar concept to hydroelectric power, so they will move the turbine. And turbine will trigger the movement of the generator and to give out electricity. Okay, but of course, this can only build along the coast, near the sea, and can only generate electricity when there's a tide. Okay, there's no difference no matter this is in higher position or in lower position. That's okay as long as there is a difference of water level. And the last one, a geothermal power. Okay, so basically it is similar to, I'll put it this way, geothermal power. So they use the heat energy trapped underground. Especially we are talking about near the place with volcanic activities. Okay, so because of the high temperature, the water that we pass into, so you may consider like this. So this is the ground, and we put the water into it. Okay, put the water into it, and after, right now we know that the rock are so hot. Okay, because of the volcanic activities. So right now these water are turned into steam. So steam would then push the turbine. Okay, again turbine, cause the turbine. So that's why this can use to turn the power, to turn the generator move, and that's why generate electricity. But of course, only some space is available for building the station. Okay, not in Hong Kong, not in Hong Kong. So at last, there's so many forms of different energy. So heat, sound, light, chemical, electrical, nuclear, kinetic, potential. So you have to note that energy can only be converted from one to another one. Energy cannot be destroyed nor created. And renewable energy, the definition. So it is the energy that can naturally replenish on a human time scale. So what does it mean? It means that the resources, I would say in this way. So human use versus uh, naturally generated. Okay, we have to compare these two. If this is larger than the rate of human use, then this is renewable energy. For example, wind, solar, uh, hydroelectric. So naturally already generated enough energy for us to use. However, some energy source like fossil fuel, fossil fuel. It takes time for nature to make another amount, significant amount of oil or coal or natural gas. Okay, however, we are using too fast. Okay, human consume these are too fast. So that's why oil, coal, and natural gas, they are non-renewable energy. Non-renewable energy. So the word of renewable on the non-renewable is comparing of the how fast we use. How fast we use and versus how fast it's replenished. Okay, so this is a relative concept. Okay, so that's it for the chapter of energy. Okay, so see you next time.